Hi, this is Alex from devstories.eu. Terraform Fundamentals, Episode 12 of 13. A local state file on your hard drive works perfectly when you are building alone, but the moment two engineers attempt to update the same infrastructure at the exact same second, you are looking at a recipe for a corrupted environment. This is the threshold between individual experimentation and team collaboration, and it brings us to enterprise readiness, remote state, and locking. By default, Terraform writes its current view of your infrastructure to a local file called terraform.tfstate. This file is the critical source of truth mapping your configuration code to real-world resources. The problem arises when you add more people to your project. If your colleague makes a change from their machine, your laptop has no idea the environment just shifted. You are operating on outdated information. Sometimes teams try to solve this by committing the state file to their version control system. This is a severe security risk. State files routinely store sensitive data, like database passwords or private keys, in plain text. The correct approach is configuring a remote backend. Instead of saving the state file on a local machine, Terraform reads and writes this data from a secure, centralized data store. This is typically an object storage service like an Amazon S3 bucket, an Azure Blob Storage container, or a Google Cloud Storage bucket. When you use a remote backend, every time someone runs a command, Terraform queries that central storage to fetch the most accurate, up-to-date picture of the infrastructure. Transitioning to this setup requires adding a backend configuration block to your code, defining where the state should live. Pay attention to this bit. A very common mistake is writing that configuration, saving the file, and assuming the state is now remote. It is not. After adding the backend block, you must run terraform init again. Running this initialization command is the trigger that tells Terraform to physically copy your existing local state file and migrate it up to the cloud backend. Moving the state file to a shared location solves the visibility problem, but it exposes you to concurrent modifications. If two deployment pipelines trigger an update simultaneously, they could both try to write to the remote state file at once, completely corrupting it. This is why remote backends support state locking. Consider an environment using Azure Blob Storage for its remote backend. Two engineers are working on different updates. Engineer A runs an apply. Before making any changes to the actual cloud resources, Terraform reaches out to the Azure storage container and places a lock on the remote state file. A fraction of a second later, Engineer B tries to run their own apply. Terraform checks the remote backend, detects the active lock, and immediately intercepts Engineer B's run. Instead of colliding, Terraform safely halts and returns an error, explaining that another process currently holds the lock. Once the first run completes successfully, Terraform automatically releases the lock. Implementing a locked remote backend is the defining step for enterprise infrastructure as code. It secures your sensitive data and eliminates dangerous race conditions. Remote state ensures that no matter who runs the code or from where, your entire team is firmly anchored to the exact same reality. Thanks for listening. Happy coding, everyone.